Delighted to be here today and present our talk on simulation of complex mining port operation with robust code testing to facilitate model longevity. So I'd just like to begin our talk with a tradition we have in Australia, an acknowledgement of country. So I'd like to acknowledge the traditional custodians of the land on which we meet today, in particular us, the speakers. Pay my respects to elders past, present and emerging. I also wish to extend this respect to other Aboriginal people and Torres Strait Islanders who are present. So a little bit about ourselves and who we are. Really, this project was a collaboration, sort of combining the best of our organisations, Fortescue and Theia. Fortescue, for those who don't know, is both a mining, energy and technologies company. And we were part of Fortescue's internal modelling. I am part of Fortescue's internal modelling and analytics team. So we bring our knowledge of our systems and what the kinds of problems that we're trying to study and how our operations work and function, along with Theia Simulation.
Hi everyone, I'm Chris. So Theia Simulation, we're a fairly new company, but we've actually all worked together for quite a long time. So we've got extensive simulation experience. We're in Australia based, mainly Perth, but we've also got offices in Brisbane and Melbourne as well. And yeah, we specialize in really building detailed simulation models and helping our companies like Fortescue to understand the system, really get the value out of being able to see the future and see how they can optimize make better decisions.
Thanks, Chris. Just a bit about ourselves as well. So yeah, I'm Rhett. I'm the superintendent of modelling analysis here at Fortescue in Western Australia. I have a background in simulation modelling, about 8 years of experience. A lot of my background has been in the mining sector. I have also worked on other problems involving energy, green energy, processing, and also bulk and cargo shipping.
I've been doing simulation now almost 20 years, initially starting at the simulation group, then Boston Consulting Group, and now at Theia, and actually quite a few of the people that at Theia have a similar sort of background. A lot of mining experience, but also a few other industries such as manufacturing as well along the way. Yiping?
And hi, I'm Yiping. I'm based in Melbourne, and I've 5 years or so simulation background. I'm more on the software engineering side of things. And yeah, glad to be here. Thank you.
So just a little bit about Fortescue as a company. So we're a global company, but the type of the part of the operation that I'm heavily involved in is our West Australian iron ore operations. So we own and run an extensive mining network up in a part of Western Australia called Pilbara. And you can see a little map of it here on the screen. So we have we have 5 mine sites, 4 of which mine hematite products. The 5th mines and processes a different type of iron ore product called magnetite. All of that is sent via either our rail network, and there's around 720 kilometres of track, and our slurry pipeline, all towards our port system. So we own the entire infrastructure from pit to port, and all of that shipped product goes through our port system. So just to give you a feel for the numbers, the previous financial year we shipped around 198 million tonnes of iron ore. So from our perspective, understanding our port operation, understanding what we need to do to improve the port operation over different timescales from a year, 5 years, 10 years is really important, especially because all of our tonnes, all of our iron ore product in the Pilbara goes through the port. It's a very dynamic sort of operation as well. So we've got a little schematic of it here on the screen. We have 3 car dumpers which take all of the iron ore from our rail system and dump it in the stockyard. We also have our CHF, which takes all of our magnetite product through the stockyard. And then there's 3 ship loaders and 5 berths, which are responsible for loading all that product onto the ships. And you can imagine there's a fair few priorities and rules that need to be modeled to correctly estimate and approximate how the port will behave. There's lots of different choices for inload and outload, and of course, there's the usual stuff in any big operation. We have maintenance of our equipment. There's failures and downtimes of various sorts. So managing this complexity, understanding what we need to do from capital, building new bits of equipment, or changing the way we operate to meet our future targets is pretty key for us, especially to meet our future iron ore ships targets. So that's why we chose to commission and with the help of Theia, build this port model that we could use in our studies. This is for us. This is like a pretty long-term investment. This model is intended for a long-term use, and it's intended to be sustainable and maintainable for us. So we had pretty clear targets for what success looked like, and what we wanted to have as an outcome. So on a technical level, we wanted our port model to be fully input data driven and parameterized. No hidden numbers behind the scenes. Everything is up front. We have full control over the scenarios from an inputs control level. We wanted also in future to be able to expand the model to downstream into the marine area and upstream to the rail and the mine. So having that modularity and optionality to expand through use of interfaces. We also would like to be able to test different types of planning heuristics for how we organise our port and how we move tons. So being able to swap that in and out is pretty key. Having clear separation of model entities, so when things change, because they always do, we would be able to do that in the future. Having our model built with some robust libraries that lend themselves well to extendability. Having a clean implementation in code base so that when one of our team picks it up 5 years down the track, they can kind of get their handle on it and build it out. And also fast as well. So, a fast model is in a lot of ways a good model because you can test things out quickly and fairly painlessly. So by fast, like runtime of less than 1 minute is okay, less than 10 seconds is great. So from a process side, we wanted it to be pretty straightforward and painless to test key operational and infrastructure scenarios through inputs and be able to turn over sort of minor experiments pretty quickly and not take months to do it. Having a well-defined methodology to data drive the model and set up scenarios is important. Having full visibility in scenario generation process also pretty critical for those inevitable times when you get asked 2 years down the track, where do these results come from? How did you get them? Having well-documented data and logic assumptions and knowledge transfer to the team was also really key so that we can continue to pass on the knowledge and have it internally maintained by our team in the future, as well as having inputs and outputs more closely aligned with our different business categories so that when we compare our model inputs or outputs to the business, it's a straightforward process. So yeah, that's why we sort of engage with Theia to help build the model and make it with that long-term view in mind.
Yeah, and this is kind of very much our approach to building models as well. But in particular, I guess because of that longevity that we were looking for, a really good testing framework was like one of the key requirements for this model build. And I guess from my experience building simulations, quite often this is something that we've really struggled with. And how do we kind of implement unit tests? And so this is the framework that we have kind of developed over time. we've sort of now at the point where we've actually, I think, did really, really well in terms of how we've implemented it and how we've been using it on this project. So it is quite happy with how it's turned out. So if we keep going. So first of all, yes, this is AnyLogic conference. We are using AnyLogic for this model build. So actually going back, when I first started simulation, we were using some other software, but it was very much like for us, moving to AnyLogic was a no-brainer. Just all of the features here that you can see on the screen, being able to use Git with it, not sort of binaries that you save, file saves. Also, just the fact that we're able to put in pure Java code to control logic. A lot of other sort of solutions out there can't do that. And so for us, the way that it just works with our workflow, how we like to build simulations, but as well as just a lot of the features inside AnyLogic, the way it's easy to make animations, for example, and so forth, and the way that it's fast is really like helpful. But one of the also key features is that we've actually been developing our own in-house libraries that, for example, like with the data-driven inputs, we've got a distribution class that we can, with just purely on inputs, can say if it's an exponential, if it's a log normal, if it's even like a piecewise where it's made up of multiple distributions. So that sort of capability of building those libraries that support our delivery of simulation is also a key sort of thing that we like about AnyLogic. So if you keep going, so I guess part of the framework for how we've developed the tests for this model, there were 3 types of tests that we really need to do. So I guess on the left-hand side of the true unit test. So when you talk about unit tests in Java, quite often it's very focused. You've got a particular method on a class that you're testing, and it's very isolated. And quite often you can do that also with if you've got maybe a particular component that you've built for the model. But one of the key sort of challenges we've found with simulation is that quite often the functionality depends on other interactions or even stepping through time. So how do we make sure that as it there's a delay, and when it comes back from the delay, it properly updates various there's the triggers that it responds to, that the ordering of triggers is correct. This is actually quite challenging with the true unit test. So one of the things we've been doing is dynamically creating fragments of model, just like very tiny mini models that we can then recreate and control carefully how we step through them. And then we have a predicted outcome from those interactions, so we can verify that yes, actually steps through those ones and it behaves as expected. So this was one of the key things that we've used here to verify that when we've developed the functionality of the model, it works that way, but also later on, as we keep adding additional changes to the model, that functionality is maintained. But also the final one, the full run test, we've found this also to be quite useful, is that you can look at fragments, but they're not going to capture the full behaviors. You might have some behaviors that go across the full model. And so we also do a full run of the base scenario that we have, and we might have tight ranges of the result have to come within that. And so, for example, if something breaks that makes things like something unconstrained and it does too well, that will be picked up by the test, and we can come back and go, hang on, why is that happening this way? So those are the 3 kind of classes of testing that we've implemented. So if you go to the next slide, I think Itping, this one's for you.
Yep. So on the implementation side, we set up and run our tests in an AnyLogic custom experiment. We use a popular, or some might say industry standard, open source Java package called JUnit to help us manage, trigger, and orchestrate the tests. So we write our tests as pure Java classes, and we run them in a suite like on the slide that you can see there when we run the custom experiment. So Chris mentioned that there are 3 types of tests: the true unit tests and the full run tests. They are quite easy and straightforward to set up, because the unit test, usually we mainly test a single Java class. Full run test is an end-to-end test of the entire model. But the submodel test, that is more tricky to set up, because we have to ensure that the submodel that we recreate represents the actual test that we will run in the production. So for example, if we want to test a material transfer, let's say, between a train and a stockpile, we would need to set up a test fixture that includes the source agent, in this case the train, the sink agent, in this case the stockpile, and everything in between, in a minimally viable configuration that still represents the actual model in production. So that can be quite tricky to set up. So when setting up submodel tests, some agents we found that can be mocked in the setup. You can see an example of a train queue class on the left-hand side that is being mocked. And the reason why we want to do that is because we want to be able to override some of the methods within the class in order to isolate the test logic. And some AnyLogic agents, we find that we have to embed them into a test main agent before we can run them properly. So when setting up the test fixture, not only this, we sometimes also use the JUnit decorators, before and after decorators, to help us set up and tear down the test fixture for every single test. So we have many tests, and these decorators is really helpful to recreate the same test fixture again and again for every single test. So once the setup is set up, we would run each test in this form, in this manner, where we would assert and test some of the assumptions before we run the simulation engine, and then we would run the simulation engine to a predefined time that we know some of the logic will have certain values, and then we would then check the test logic to see if they have those expected values, and if they do, then we would say the test would pass. So an example of a screenshot of the test is on the right hand column, where you can see the engine is run up to 102 minutes, and then we do our assertions. Yep, and then we have many tests. We have about 126 tests. Now, if we go to the next slide, we find that from experience that some AnyLogic features makes unit testing quite challenging. So one of them is that there isn't a built-in framework in AnyLogic where we can do unit testing. So we have to rely on JUnit. Secondly is that we find that sometimes AnyLogic agents, when we initialize them with the default values, they can behave differently during tests. So we have to be careful of that. And then lastly, animation is really hard to test. So far we have not found a good solution to do so, and we mainly bypass or turn off animation for now, even though we know that sometimes runtime error can occur in the animation layer. So yeah, that's something to take note. So yeah, that's a lot of work and challenges that we have to overcome. And now back to Chris.
Yeah. So as I think mentioned, and is also some of these, particularly the submodel tests, can be time consuming to write. And so in general, would you say about 50% longer kind of development time to write all of these ones? Another big challenge is quite often where we might refactor some bit of code and it might actually break the test. And we look at the test, it's actually nothing wrong with the model logic, just that the tests were written in a way that assumed certain way of that there was some behavior that just changed how it's implemented. And so we need to actually then fix the tests, which creates like this admin burden. And we've had to be pragmatic because even so, we haven't tested absolutely everything exhaustively. If we did so, we'd probably spend more time writing tests than actually writing the model. So there's some pragmatic approach required there. But definitely, it's been wonderful to have these. So often, when we've written some logic, and then I noticed that actually these tests are breaking, I can get the feedback straight away that actually something is broken, or in particular, where I've changed the logic in one area and it breaks something completely unrelated to how I would have thought, rather than that being hidden and only sort of coming up much later down the track, if at all. I can see it straight away, and because I can see it straight away, I can see more clearly what might have caused the break. Whereas traditionally, what I've found is that you might find that there's a bug. You have behavior that's unexpected, and then it can be very time consuming to do debugging to track down exactly what might be causing that error. So having these tests that can detect things right away is really helpful, and also I guess that confidence that we can see pick up issues that come up. So I think thanks to this largely, the development of models actually kept pretty much on track. We haven't had any major blowouts in terms of the development time. So you definitely would credit this. So overall, I would say that it's been worthwhile.
Yeah, one other thing I might add as well, Chris, about the unit tests. They're pretty good on ramp as well. I found for some of our new team members getting into the model. You know, it gives a good access point to seeing what the behaviors are intended and what the code is meant to be doing outside of the documentation. So it's definitely had, I feel it's had that kind of benefit as well.
Yeah, and also another benefit is that we've got a system where we've got a main branch. We use pull requests in order to merge development into that, and so being able to demonstrate that your branch is passing all the tests, it makes a good review mechanism for merging into the main branch.
Yeah, definitely. So just before we get to the end, just show a little bit about of the model itself running in anger. So here's an animation of our port model. The animation itself has also been an excellent tool, helping not just showing all the other stakeholders internally what's going on, but as a debugging mechanism for what's happening and when things are going wrong or why they might be. So you can see we've got the train queue represented at the very bottom, all the way through the shipping at the edge and material flowing in and out of the stockyard. I'm just mindful of the time. Just wrap up. I feel like we've had a lot of wins in the project. 120 plus unit tests written. We're sort of sitting pretty close to our 10-second replication runtime. We've got our full model documentation. Models fully inputs driven port layout. Our validation so far is within 10% of actuals and improving, and we've got a whole suite of test scenarios and studies lined up wanting to use it. So might just stop the share there and have a look at the QAs.
Yeah.
Oops, QA.
Okay, why need an in-house distribution library? So the main benefit of that is it just helps us develop faster. Quite often, if you build a simulation multiple times, you're repeating code that you've written before. So it just makes it a lot quicker to develop that again. How do we deal with randomness within the model with unit tests? Very easy. We just use a constant value. So our distribution class that we're using, we can set up to be whatever we want. We can even have like a predefined sequence of numbers, so that, yeah, definitely you don't want that randomness in there when you're doing your tests. Create a fragment model. Do you work backwards from the full model, or do you manually create it from scratch? So yeah, we dynamically create it. So we've got a class where we will just create new instance of this class. Let's try just dynamically model code will structure it in that test class, so then create that initial version. How do you test end-to-end tests? Do you generate output from simulation, validate and check, and run another output? It's still the same. Yeah, so what we've done is we've got the base scenario. We use a JSON file, so our library also can just pass that JSON file to set up all of the model, initialize it. So we've got a standard scenario that we run through in batch mode, and then we've got a KPI file that has the results, and we've got a select few of those KPIs. We just have a range, and the test passes if all of those KPIs are within the range that we've predefined. Sometimes when we've changed things, actually improve performance, it might actually move it, and we go, okay, we need to actually update the range, but it's a conscious decision when we do that.